I guess if you guys are interested in chemical reactions, then it is very important to do the transition state search, because this kind of calculations will give you the reaction barriers and also give you some insights about your reaction mechanisms. So to do these calculations, you need postcard and outcard from geometry optimization calculations for initial and final structures. You also need some standard input like in-car, podcast, and key points, and also, of course, the script for job submission. And the third step, I guess, this is quite important because you need to have some basic knowledge about your reaction pathways. So if you have some knowledge, then you can input some reasonable initial gas structures, which can be used as intermediates to bridge between initial reactant and final product. If not, then I guess you can use this script just to do a linear interpolation. But I guess this is not very good. But still, you can do it. So here, the IS means the initial structure postcard, and FS is just a final product postcard. And N is just the number of intermediates you want to insert between initial and final. So after we run the script, we'll generate several subfolders, and each subfolders will have some postcards. And I guess you need to make sure these postcards are reasonable. So here is a output. And then finally, you need to put your initial and final postcard and outcard. First, put the initial reactant postcard and outcard into folder 00, and put the final product postcard and outcard into folder 04. So here we assume we insert 3 intermediates. If you are inserting more intermediates, then change the folder name to n+1. And the left side, this is just an in-car. And then there are several tags we need to focus on, like protein, like this one, and also IOPT. So basically, the IOPT just select different kinds of optimizers, and some details can be found in the website, like I show here. And the right side, this is the script for job submission. So I guess we need to pay attention to this line. So instead of our traditional job submission, we use a different version of that. So if your job is successful, then you can use this command to process output. So here is an example. So basically, the second column, this is the false. The third column, this is total energy, and the final column is the relative energy. So as we can see, we have a transition state here, about 5 electron volts. So here is another example. So basically, this is a transition state search for peptide bond formation. So basically, we insert 7 intermediates, and the middle one, this one, is just a transition state. So that's it.
Okay, please join me. So, any questions in person or online?
So I have 2 questions.
Yeah, go ahead.
So first, this x-axis reaction coordinate you calculated later on in MATLAB or somewhere else, correct? Or
yes, you can do it, but I guess in the VTST code I shared before, there is a standard script to process this kind of data.
So what is x-axis here?
This is just a reaction coordinate.
No, I know. That was listed in the previous study or no? In the data that you generated?
So basically, it's some kind of a code in this kind of folder.
Mm-hmm.
But I guess I just need to double check the script name. But
okay.
But it is there.
Okay, and in slide 2, I didn't get LIS and FS. How did you assign them?
It's just the postcard file for your initial reactant. You can name it whatever you want. I just gave it a name IS.
I get a little confused. Could we assign a file to a name? IS equal postcard?
Doesn't matter. I can do this way.
That was, I had another, okay, I get it.
So, I mean, likely IS and FS is not like its initial state and final state abbreviation, right?
Mm-hmm.
Mm-hmm. Okay, I didn't use this comment before assigning a file to a character, to a variable. Okay, I got your point. Thank you.
So, Dr. Han, I have a question.
Okay.
So, you said we need to have the postcard and outcard of the initial and final structures. For this case, for example, you mean by initial, you mean the postcard and the outcard file of the 2 amino acid, and the final is the dipeptide structure?
So let's look at the final slide. So basically, this is the initial structure, and this is the final structure. You need postcard and outcard for initial and final.
Okay, thank you.
Any questions in the room?
Could you re-go over what the columns in the DAT file are again?
This one, right?
Yeah.
So basically, I guess the second column, this is just your false, because this kind of transition state search is false-based. And the third column, this is total energy, and the final column is relative energy with respect to your initial structure.
So, Dr. Han, you for the last plot, you considered the final column as the y-axis, correct?
Yes.
And for the x-axis, you said by generating or by executing this command on top of this slide, it will generate another file that has the coordination inside of it, yes?
Yes.
Thank you.
So what's the name of this file that contains values of reaction coordinate?
I need to double check, maybe distance or something like that.
Okay. If there are no oral questions, let's look through the chat.
There's some question about AEB. I guess it's largely the elastic band.
A non-elastic band? Okay.
The second question, why is potem equal to 0? and SW equal to some very large number. So I guess this is a requirement for the code. So basically, the VTST, those guys who write the script, they have different version of optimizer for VASP. I guess to enable their version of VASP, you have to set podium to 0. Why SW equals to a huge number? Well, because this kind of calculation is very difficult to converge. So here I'm just trying to make sure we have enough ionic steps.
Okay.
The one submit job for all sequence can restore as managed job system. No, I guess you just need to submit once.
Okay.
Yes, you can submit this kind of job for limited number of steps and then restart. Just convert count card to postcard again.
Okay.
So, Dr. Han, can you please go to slide number 2?
Mm-hmm.
So for the n, number of intermediate you want to insert, what does it mean, number of intermediates? So how we should specify the correct number?
Well, this is just your personal choice. Because this number differs from system to system. Like here for the peptide, we use 7.
Yes. So how you understand it is 7 for this system? Basis on base of what information you
okay,
say
so
that?
maybe this is not correct, but this is what I did usually. So basically I start from a very small number, like 2 or 3 intermediates. Then I just increase systematically until from your calculations you can see some trend if your calculation is convergent or not.
I see. Okay, thanks.
Yep.
So the larger number would be better, but it would be too expensive. So when one person finds a balance between numerical cost and precision, right?
Yeah, makes sense.
I guess if you have some solid knowledge about your reaction pathways, then you can increase your number of intermediates. Otherwise, it's like you artificially fix your reaction pathways by providing too many intermediates, which is not good. So I guess there is a balance, between accuracy and efficiency.